What does it stand for? What does the Greek word poly stand for? You remember? Many. No. Gon is sides. This is many sides. Many-sided figure. When I say this, there are types of polygons. There's concave and convex. There are two types of polygons. You have what are called concave and convex. Convex are the normal ones. Concave are the ones that have sides that work inward. That would be considered a concave polygon. It's when sides move inward. Convex are ones that all have sides on the outside. So that's when you get your ones like this. Those are your normal ones. Okay. Think of it as caving in. Yeah, like you just said, it's like inside of a cave. To be honest with you, that's probably the only time you're going to see the word concave versus convex. I believe you might see it as a vocab word. That's about it. Other than that, there's really not a whole lot going on with concave and polygons. I think if I ever used any in college, none of the rules really don't go well at all. So yeah. So what we do then is we name them because we can. What is a three-sided polygon called? Boy. So we have three sides. What's that? You know, right? What is a four-sided polygon?
Square.
Oh. No. What is it? What's the generic? Quadrilateral. Okay. A four-sided figure is just called a quadrilateral.
And then within that, you have kites, parallelograms, rectangles, squares. The famous rhombus is in there.
Quadrilateral has four sides. What is a five-sided?
Washington, D.C., there's a building called.
Pentagon was built Pentagon.
So you have five sides, which would be a pentagon. The six sides is your hexagon. If you ever go to IKEA, you will hate these little things. Polygon. Is that right? Do you need a pen? Okay, let's write something down. Seven sides. Now you probably know it's something different than what they probably teach. There's two names.
Right.
There is a septagon and a heptagon.
And what is the?
Eight generational.
Okay.
So seven-sided figure is a fun one to draw.
Yeah, I'm looking at the board.
Yeah.
Yeah, we tried to do a seven-sided figure at bank in marching
Thanks. I did it all myself. See?
Straight lines.
Aren't all lines straight?
No, no, not all lines are straight.
So it's a heptagon or a septagon. The reason why I'm listing out all of these things is because vocabulary-wise, we'll say, hey, you have a hexagon, and then you'll have to go from there and know how many sides that is. Okay. Gee, what is an eight-sided figure called?
Octagon.
Okay. Stop sign, yeah. So eight is the octagon.
Fun fact, so septagon is 7, octagon is 8, and yet September is the 9th month, and October is the 10th month. And you can think, what ancient Roman, was it Caesar Augustus, who added the 2 more months? Or was it after?
It was Augustus.
Augustus, who added the 2 months afterwards, and.
Added August celebration.
Oh, me too. Wait, I forgot all of that.
It's not
I know.
The 9 is a nonagon. Exactly.
And 10 will be a tenagon.
So 10 is the decagon because decade is 10 years. So you have a 10-sided is the decagon. The 11-sided one
It's starting to look like a circle.
11 again.
is exactly what it's called.
They
got lazy.
Don't they wait until they get to 15? I thought it was a
Nope.
undecagon and a dodecagon.
There's a dodecagon, that's 12, and then after that, then they got lazy.
What about a tetra? Isn't there a tetra?
That's Tetris.
It was called 11 again
And I think it's a tetradecagon. I thought you could, no, it's.
Tetrahedron. That's
No,
three-dimensional.
three-dimensional, yeah.
So, oh. I've always noted is that at 11 they switch to 11 gon.
Decagon, because un is like 1,
Right.
and then deca 10, and then dodecagon.
But that just means you have one decagon?
No, it's 1 plus 10, just like dodeca. It's
11.
1 plus 10. Stop it.
Go ahead, you have the internet.
Okay.
And then the last one that I'm only going to hold you guys responsible for is a 12 gon.
This is the 20 deca.
Wait, so 11 is just gone?
So once we get.
Yeah, it's 11 gon, and I'll explain what happens now. This is called a dodecagon.
It's starting to look like a circle.
And that's the idea. As more sides you get out there, the more it starts to appear to become a circle. And there's a reason for that because of the angle stuff.
So wait, how many sides?
What's that?
How many sides does it like take to make it into a circle?
If it has sides, it's not a circle. If it has sides, it's not a circle. A circle is defined by a set of points that are equidistant from one singular point. So all points around a circle are all the same distance apart, whereas if you had a side, each part, if I put this as a centerpiece, each point here is a different length
Triangle.
as you go through it.
We have
It's never going to be a circle. They may have sides.
Correct. What is it called? It is an decagon.
I was so close.
From the Latin. Thank you, from the Latin.
We're getting a polygon.
I wonder what like
Dust up.
100 is
It's just 100 gon.
100 like, is it just like a circle basically?
It looks like it, but it's not. And this is what we were just talking that the more sides you put into a polygon, the more it does appear to look like the shape of a circle. But a circle is defined differently. That's why it's not a circle. So what do we got? Is it so it's an decagon?
Yeah, and it's a tetradecagon for 14. So I think once you get past
Un is
14,
one
now
and
it's just
right.
15 gon, 16 gon.
Okay. But I think,
No, it's on.
all right. So what I want to do then is I want you guys to start to think about when you have these are the ones that we're going to hold responsible for knowing. If you want to call it an decagon, that's fine. I'm going to call it an 11-gon.
Okay.
After 12, everything just goes to 13-gon, 14-gon, 15-gon, and so on. A 17-gon has how many sides? A 33-gon has how many sides? We're going to be just fine.
And over 6,000 gun has
All
how many
right.
sides?
So what I want to look at though is interior angles. Yo. What's that? Oh yeah. There's a lot of. They go through names. No, you don't have to draw. What I'm trying to see if you guys can figure this out. So, what I want to think about here is what's called the interior angle sum. We all know how many degrees are inside of a triangle, right?
Yep,
How many?
No.
180.
All right. So you know that this is 180 here.
I said it was 280.
Excuse me. When I go to the next one, how many triangles can I draw into it that don't overlap? You know what I mean by not overlapping? Right. I can't go 4, but if I go 4, then I cross over them. So really all I can do is 2. Well, and each triangle has how many degrees? Which means how many are in a quadrilateral? 360. Pentagon. How many triangles can I throw in?
540.
3.
Or, excuse me.
So we have 1, 2, 3 of them. Okay. And the next one is how many?
Oh, and then just keep going.
Yeah,
There's
you
4.
just add 180 each time.
Well, take a look at what's going on. If you have 1 triangle, 2, 3, 4, look at your sides. How many sides did each one of these start with? This had 4 sides, right? How many triangles were in it? This had 5 sides. How many were in it? This had 6. How many were in there? 4. That has 7. How many are in there? This has 9. How many are in there? 7. The pattern that happens is it's 2 less the number of sides. So each and every time, the sum of the interior angles, bless you, in a polygon is number of sides minus 2 times 180. So if it has 9 sides, it's 9 minus 2 times 180. If it's 4 sides, it's 4 minus 2 times 180. If it's 3 sides, it's, bless you, 3 minus 2 times 180, and so on and so on and so on. No matter what, it's not a polygon then. If it's just 2 sides, it's going to be a polygon. Remember, the polygon's going to be an enclosed figure. You can't enclose a figure with 2 sides. Right. Well, you can enclose a figure, but then you're talking about a curve. All right? Now, think about the outsides. Okay? Think about the outsides. Oops. That button is very nice there. When you're talking about the exterior angles, you're talking about the angles on the outside. Oops. That's these. Those exterior angles. Okay. Now, if you're going around an object, how many degrees does it take you to get around an object? 360. Okay. If I go around an object, how many degrees is it? Okay. If I go around an object, how many degrees is it? Does the object shape matter?
No.
No.
Size does not matter.
What's that?
Size does not matter.
Oh, that's such a
Besides,
bad joke.
that was bad. I'll give you credit, Don. That was pretty good. That was like a, yeah. The number of sides doesn't matter for the exterior angle. Because how many degrees does it take to get it around an object no matter what? 360. So the exterior angles and that's always. Always, always. It doesn't change. It does not change. Okay? Those are the two main things about angles, about how they work. Now, one other quick definition here is called a regular polygon. A regular polygon. You ever heard that before? I think we've said it before.
It's not your.
Do you remember what it was? No.
Look it up. You got the
Oh, spit on whiskey.
That was fun. Regular polygon.
Spit on me, you die.
Ooh. Regular polygon just means all the sides and all the angles measure the same. Now, if you think about it, we've actually dealt with that before. Equilateral triangle. An equilateral triangle is a regular polygon. All the sides measure the same, and all the angles are the same. All the angles inside a regular polygon equal how much? I'm sorry, in a triangle. How much were all the equilateral triangles? Angles? 60s. Okay, they're all 60. Because we knew how many degrees there were. It was 180. So if I want to think about, again, going back to each one of these, if I knew that this was 180 degrees, the regular polygon all had 60 degrees. If I knew that this was 360, if I divide that by the number of sides, it would give me each angle, which would have been 90. If I take this one, we take 5 minus 2 times 180, and I divide that by the number of sides, it tells me each individual angle, because there's 5 of them. Okay. Now, there's 2 ways of going about figuring each of these angles out. One way, I'll do it with an octagon. A regular octagon angles. There's 2 ways to figure out the measurement of each individual angle in an octagon. There's a real easy way, and then there's a more straightforward, formulaic way. How many sides are in an octagon? 8. So if I figure out the sum of all of them, each one of them is going to measure the same, which is divided by the number of sides. Do you agree? So what we would do is we can do this. 8 minus 2 times 180 divided by 8. I can throw that in my calculator. That's the formulaic way of doing it. If you throw that in the calculator with the fraction bar, it does it for you, okay? I believe you get 135 for each of them.
Yeah.
Okay. That gives you 135 degrees for each individual angle going through. Or, think of it the other way. How many degrees is it to get around an octagon?
360.
So if it's 360 degrees to get around it, we know that wouldn't each of these angles on the outside also have to be the same?
Yeah.
Well, how many outside angles are there? There's 8 of them, right? What's 360 divided by 8? No. 45. By doing it this way, you get the outside angle. Doesn't the outside and the inside form a linear pair? Which means all I have to do is find its, which one is it, complement or supplement? Supplement. And there you go. This is a little bit quicker. Working with the exterior angles is usually quicker. Okay? You can do it either way. Or take 180 minus all you're doing is finding the supplement. Either way works. Okay? Either way works. Doesn't matter. Okay? Excuse me. We go both ways with it a lot. I usually show either way. I always thought that it's easier to start on the outside and work my way in. This idea of finding these angles on the outside, it doesn't go away. We use it over and over again, pretty much here on out, because eventually we'll start doing this, figuring out all that, and working our way out. Okay? There's a lot of trig and ugliness that can happen within these things. Okay? Let me show you an example.
That's a lot of folders.
Nothing better than being, what do you call it?
Organized.
Yes, correct, that was fine. Let's find the sum of the interior of a 13-gon. I want to find the sum of the interior of a 13-gon. This is where it comes into play that you have to remember what exactly are you looking for. Are you looking for the interior, the exterior, each individual angle, so on and so forth. This says, what's the sum of the interior? So which formula do you use?
The n minus 2.
Yeah. So, what is it equal to? Was it?
Back.
Wait, I'm completely confused.
With what?
Oh, this.
It's a formula. The sum
Oh,
of.
never mind. I figured it out.
Okay. Now, if I wanted to find the sum of the exterior of a 13-gon,
It's gonna be 360.
why?
Because earlier you said the sum of angles in the sum of exterior angles is in a polygon is always 360.
So the sum of the exterior is always 360. Now, if this was a regular 13-gon, what is each interior angle equal to?
180.
Excuse me. Yes, ma'am. What'd you do?
I did 360 divided by 13,
Mm-hmm.
and that was 27.69.
We'll write this down. So you did 360 divided by 13. All right.
And then I did 180 minus
You got that?
27. Yeah.
And what was your answer?
152.31.
152.31. There you go. What's that? For regular, if you're on the interior of a regular, you can't find the interior angle of the non-regulars because they can be anything. Okay, they can be anything. That's the only time we worry about it is if we're doing regular polygons. Okay. Yes, ma'am.
Yeah, I just did 360.
You could do that. That's the other way we do it. If it's just trying to find the sum of the interior, that's the total amount of degrees. That's all you do. If you can do that also by doing it this way to get the interior, or the way like Hannah did, where you just got the exterior with the wing. Either way it works. You get the same answer. All right. Let's work backwards. they give you, the sum of the interior is blah, 3240. How many sides is it? So now what you have to start remembering is, what formulas do you have? I have sum of the interior, sum of the exterior, and then I can find each individual regular polygon. Well, I'm not working with the exterior angles, am I? So I can throw that one out. Am I working with a regular polygon here? No, I throw that one out. So what I have to do is fall back on the n minus 2 times 180 has to equal 32. Two-step equation. How do you undo multiply? So divide by 180. And then what's that? 118.
Yeah.
Now what do you do?
Add 2 to both sides, I'll do this one.
It's a 20 gun. So yes, sometimes you work backwards. And this is where it twists the geometry part back to algebra. You know how to do the algebra because you guys all took algebra before. You're just using geometric terms within it. Okay? You're just using all those terms with it. Okay?
Question.
Sir. Do the same thing. Find out how many sides. You have 70, 75, 60. How many sides? Okay.
42.
We'll write it down, okay? You might want to write it down too so you remember it. That'd be helpful.
Yeah, need it. I'm doing it.
So, once again, take 75, 60, divide it by how much? And then what?
42.
And then you add 2. So you have divide by the 180. You guys said that this much was how much? The- And there you go. It is relatively quick, okay? Now, the other stuff that we do, so we build out like this. Now, before you worry about trying to draw it, if you need to solve for x, are you working with an interior or an exterior angle? Interior. Does this appear as if it's going to be a regular polygon?
No.
No. One reason why we know it's not is because they have a bunch of different angle measures. So you know you can throw that out. But what you need to do is figure out the number of sides. Should the number of sides equal the number of angles? Okay. Count. 1, 2, 3, 4, 5, 6, 7.
Hey, I can count.
So if you have seven sides, could you figure out how much or how many degrees all of them have to add up to equal?
7 minus 2 times
Right. And you get how much? Was it 900? So all of those have to add up to equal how much? 900. So you're creating your own equation then, basically. You're figuring out how many degrees are inside of here, which you've done if it was a triangle, you did this problem. Now they're just putting more sides to it. So you have 145, 112, 99, 133, 156, plus, what's x and 2x? 3x. And I just add those up in my calculator. Does that make sense? Yeah, it shouldn't be very difficult, I hope. Okay. It's just a different way of looking at it. How much is it? X is 85? Everybody agreeing, disagreeing?
I'm agreeing.
80.
What, you got 80?
I got 85.
85, okay. Everybody okay with just leaving it as X is 85? You're able to press buttons okay? All right, let's make it scary.
What?
Why not?
Oh, but
Are those interior or exterior angles?
Exterior.
What do they have to add up to equal?
360.
360. Do I need to do this problem?
No.
No?
We're done.
Well, I just wanted you guys to see that you're just looking to see if it's an interior or an exterior angle. Are these inside or outside angles? Outside. What's the sum of the outside always?
360.
So you just add these up, set it equal to?
385.
Stop it. Okay? I'm just showing that. Each interior angle of a regular n-gon, which means polygons, you don't know the number of sides, equals 108. So this is dealing with the regular polygon stuff. We're going to the regular polygon, you've got this one here, which means if each interior equaled 108, actually, I'm going to show you guys what I draw a lot of times with these. Do you guys agree that no matter what, with every polygon, there's always going to be 3 sides, at least? Now, obviously, I don't know if it's a triangle or whatnot, but at some point in time, you'll have basically at least 3 sides and 2 angles, or somewhere around there. Now, what I do is, if I label this as 108, and I know that this side has to be 108 as well, because each one will be the same. I always think that it's easier to figure out the number of sides by working with the outside angle. Because outside angles always add up to equal how much? 360. So if I know that all the outside angles excuse me, add up to 360, what is its outside angle if the inside is 108? 72. Good, it's the supplement. So if we know that if I take 360 divided by the number of sides, it's going to equal how much? It'll equal 72, won't it? We have, haven't we? Isn't this fraction equal fraction? Did I change anything? What did you do when you had things across on the diagonal from one another? You can, but wasn't it easier? Remember when we did this a lot? Yeah, exchange-o, change-o. Remember, you can rewrite these things. That doesn't change, does it? Is that still true? 2 over 4 is the same as 3 over 6? Same deal here. Exchange-o, change-o. If you take, this is a nice thing to remember. It's a little hint. Take 360 divided by the exterior angle, you get number of sides. If you take 360 divide it by, this is only for regular polygons, only for regular, okay? You take the outside angle, or say 360 divided by the outside angle, it'll always give you the number of sides. It's a nice little trick to remember. It's a shortcut way of doing a lot of these problems. Because like I always say, it's always easier to work with an outside angle. There's less math involved. You have to work
And
it
it
out.
only works for the regular polygons?
I'm sorry, what's that?
It only works for the regular polygons?
Yes, sir. This only works for regular polygons, because this is the only time they're going to ask you questions about that with regular polygon stuff. Okay? I think that's enough for right now. This chapter is like stuff. Yeah, the trait stuff is all there. Wish you could books. So excited. Have I mentioned that yet? All right. So back to you guys all remember how to find the book stuff?
What's the name?
It's not a failure, man.
Say 8, so.
Alright, yeah, that's good.
Okay. I've just sectioned it up a little bit for you. All right. Let me remind you guys how to find the book stuff real quick from the website.
Yeah, I remember.
Yes, sir.
Can I take a book home?
Yeah. Just a quick reminder. We are in chapter what?
8.
I know, right? Hey, where do you think I'm going to click for the textbook?
You're gonna pull down to find it.
That's right there. Now, what happens is it starts on chapter 7, so don't freak out. It was set up in terms of 2 chapters each. Whiskey, stop.
21st.
Watch is right.
And you just have to scroll through. That's all. And there you go. Okay?
You need the whole one? Give me the
And there it is. All right. So just click, and you just have to scroll down because the textbook PDFs are done in 2 chapter increments. That's all.
What was the page number?
Oh, it's 510. It starts on 510. I'll put it back up. There you go.